What's going on, guys? Today we've got the Raspberry Pi 3 camera, the Raspberry Pi AI camera, and we've also got the Raspberry Pi 5 with the AI hat on it. And in today's video, I'm going to break down all of these devices, we're going to set them up, run some benchmarks to see which of these performs the best, and I'm going to share some things you may not have known about these products. Before we jump in, I do have to give a special thanks to Raspberry Pi. I let them know that I was planning to make this video and they sent this AI hat out completely free of charge, making this comparison video possible. So, thank you, and now let's dive into it. Starting with the camera module 3. Now this retails for about 50 Australian dollars. It has a 12 megapixel camera and you can get somewhere between 720 to 1080p resolution when recording video. It's designed to work with your Raspberry Pis, but you are going to be limited by the processing power of the model that you're using. For example, if I hook this up to my Raspberry Pi 5 with 16 gig of RAM, it's going to perform significantly better than if I hooked it up to my old Raspberry Pi 4 with only 8 gig of RAM. It's going to get bottlenecked by, I'm assuming, the CPU on these devices. In the box, now I did purchase this about 6 months ago, so I am going from memory. We received the camera, I believe another cable, and at the time I ordered a spare. I can confirm when the AI camera arrived, it did come with both cables, so I'm pretty sure I had both in the original box with this Pi Camera 3. Now this is important because depending on the type of Raspberry Pi you have, you may need a different cable. The newer Pi 5s use this thinner cable down the end, whereas older devices like the Raspberry Pi 4 will need a flat edge like this. If you've ordered a camera and the wrong cable is in there, it's really easy to change. There are 2 tabs on either side. You just pull them down, the cable will come out, and you put the correct cable that you need in and close it up. To insert the cable, it simply slides underneath the protector. Gently push it in and make sure that you've got a flush finish. You don't want it slightly angled like that. Once you're happy that it's secured in place, go ahead and press either tab down slightly. You should hear a click and feel it locked into place nicely. If you're using this cable, I believe the blue side needs to be facing away from the camera, like this. And when we connect it to our Raspberry Pi 4 over here, we need to make sure the blue tab faces towards the Ethernet port like this. This is very important. It has to be done correctly, otherwise the camera won't work. I believe on the Raspberry Pi 5, the instructions might be slightly different, so just make sure you double check. Again, we're going to gently lift these tabs. Gently insert it behind the protector. It was a bit fiddly. It should push all the way there so that you can't see much of the silver anymore. And once you've got into that position, then gently press the plastic cover down on either side. You will hear it click into place and it should look something like that with the blue line facing towards the Ethernet port. Now we're going to give it some power and see how it performs. Now that we've given it some power, we're going to remote desktop into our Raspberry Pi. So I'm going to fire up Tiger VNC. We're going to open up a terminal window and we're going to run this command. This should bring up the video feed for us. Right now, my Raspberry Pi camera is sitting in that tray, looking up at the roof, which is quite boring. So let's go ahead and fix that. And we should see in real time. There we go. Let's point it towards our desk. Okay, that was really fiddly. I kind of just made a makeshift thing and I've used a bit of sticky tape to just attach it to the back of my MacBook Pro. As you can see, we're getting 30 frames per second. Now, if we close out of that, here are some cool commands we can run. The first thing I'm going to do is quickly make a temporary directory. And we're going to navigate into that. Now to take a picture, we simply use this command. It'll pop open the screen and take a still image. So if we close out of that, go here. Here is our still image. And if we want to take a video, we can use this command instead. And we'll close that, and we should have video. Yep. That did look quite janky to me, but I'm probably maybe doing something wrong in my commands, or I haven't set something up properly. Now, the last thing I want to test before we head on over to the AI camera is how does this camera handle AI related tasks? How well does it do object detection? In order to do that, we're going to follow these instructions. So there are a bunch of packages we need to install. Going to head back to our terminal and we'll simply paste these in to install them. Now it is giving us an error message when we try to install Ultralytics. Basically, it wants us to run it in a virtual environment. I actually went down that path and ran into just too many roadblocks where it wouldn't work. For now, I'm just going to do something a little bit risky and chuck this in. Go ahead and hit enter. The short version is, instead of doing it in an isolated environment where I can't potentially break other things, I'm installing this Python package system-wide. All right, we are back in business. So I did have to give the Raspberry Pi a reboot before it would pick up the YOLO library after installing Ultralytics. So after that reboot, we open up our command prompt and we want to go back into our temporary directory. We're going to quickly create a new Python file, so I'm going to call it yolo.py. And I'm going to paste this code here that I got from online. This should spin up an application that will do object detection using YOLO. I'll put links to all the source code down below in a GitHub repo for you guys. We're going to go ahead and save the file. And we want to go ahead and run our script. So I'm going to do python3 yolo.py. This is going to spin up a screen and we should see object detection happening. Now, the very first time you run this, it may take a while to start up because it is downloading the model behind the scenes. Subsequent runs should be a lot faster. This is the performance we get, so we can see it is quite laggy because we are relying on the Raspberry Pi 4's hardware itself. If I had to guess, we're getting about 3 to 4 frames per second, but it is accurately detecting me, and the detection is actually quite quick. So if I walk out of frame, yes, it's a bit laggy, but if I then hop back in, instantly, as soon as I hop into frame, it's got me. Now this is using a pre-trained model, so we'll see if it can detect other things. I'm going to hop out of the frame, see if it can detect a chair. Maybe it's not enough of it. What about a phone? Yep. Pretty cool, but it is a bit laggy, which was expected. Now I'm going to go ahead and exit out of that script. The next thing I want to do is quickly edit that script. What I want to do is go ahead and change the model that it's using. At the moment, we're using quite an older model, the V8 model, which was the originally recommended one for the Raspberry Pi 4. There is now version 11, which is meant to be faster yet again. So I'm going to go ahead and just replace that line and chuck that new model in there. Go ahead and save the file. We're going to run it again with that new model to see if we get any noticeable difference in performance. It's hard to tell. It is still laggy, and if anything, I feel like that's a little bit slower. So I'm going to go ahead, exit out of the loop. I'm just going to chuck that back to 8, and that will be the final version that I put in the GitHub link down below. So that gives us a really good baseline. Now we're going to see how that compares to the AI camera. Let's open it up. Now these cameras do come in an anti-static bag, so make sure you ground yourself, so touch something metal before touching these. Basically you want to make sure you don't have any static electricity on you because you can damage these. In the box you get the AI camera, which by the looks of it has the correct ribbon cable that we need. And it also came with another cable which is compatible with the Raspberry Pi 5. Given we're going to use this on the Raspberry Pi 4, I'm going to go ahead and take this as it is. And we're going to swap these over. So we're going to go ahead and gently tug at either side. You should hear a click and then you can pull out the old camera and we'll place in the new one. Remember, the solid line has to be facing towards the Ethernet port, so we're going to plug it in this way. Gently push it down. And once it looks kind of like that, nice and flat, go ahead and press either side down to lock it into place. It should look something like that with a little bit of the gold sticking out. We're going to go ahead and give it some power. I'm going to go ahead and set up in the exact same position that we had the last camera. We'll give it a sec for our Raspberry Pi to come online, and we'll remote back into it. Because the AI camera does all of the processing on the camera itself rather than our Raspberry Pi, the setup is slightly different. We're going to go ahead and follow the official guide. Again, I'll put all the links in the description down below to make it super easy for you guys to follow along. Here are the 3 commands we're going to run. First, we're going to update all of our software. So we'll go ahead and copy that. Head over to our terminal and paste it there. Once that's finished updating, we're going to install the required firmware for the camera to run correctly. And then finally, we're going to reboot. Now this is the second time I've run these commands on this machine, which is why it was super quick. When you do it the first time, it's going to take you about 10 to 15 minutes to download and install everything. So we'll get it to do its reboot, and with any luck, the camera should be up and running. Having a look at their official guide, they do give us a command that we can run, which makes direct use of this AI camera. So let's see how it performs. Open up our command prompt and paste that in there. Hey, that is looking good. We are getting a full 30 frames per second. It is accurately detecting a person. What else do we have? Now it is kind of dark in this room. We're filming at nighttime. Surely. Yeah, backpack. Super smooth. Super. Incredibly smooth, 30 frames per second. Now, some of the object detection was questionable, like not correctly picking up a phone or calling my chair a person. I'm sure if we plugged a different model in, like YOLO, that would fix it. Something interesting to note, even though a lot of the post-processing is happening on the actual camera, rather than the Raspberry Pi itself, I can still feel it's quite warm when I pick it up to touch. So if we just have a look at the temp, we can see it's idling around the 60 degrees Celsius temp, which is not terrible, just something to be aware of. You may want to invest in a fan. To recap our findings between these two devices so far. The Camera 3 versus the AI camera. Camera 3 is about $50. The AI camera is about 2.5 times more expensive at $125. Similar capabilities when it comes to photo and video, but huge differences in performance when it comes to AI tracking. With the Camera 3 on a Raspberry Pi 4, we were getting about 4 to 5 frames per second, whereas using the AI camera, because it was doing all of the post-processing on the camera itself, we were getting a solid 30 frames per second the entire time, which is pretty cool. But in practical terms, what does this mean for you? Well, if you've already got a Raspberry Pi 4 or a Pi 5, you might be able to get away with the Pi 3 camera. It's almost a third of the price, and the only sacrifice is your frames per second. Like we demonstrated, the AI object detection was still really quick. You were just missing out on those frames. So when you viewed it in real time, it looked choppy and out of place. And obviously, if your use case is to track like fast movements, then AI camera the whole way, you're going to need this. But if your use case is something like mine, maybe you want to detect movement throughout your house and turn the lights on 100% of the time, I think this would get the job done for a third of the price. Now, where this is really cool is this works with any Raspberry Pi device, which means we don't need to get a Pi 4 or a Pi 5. We could chuck one of these onto a really cheap Raspberry Pi Zero wireless and get insane 30 frames per second AI performance. At least in theory. So if I was looking to do something like a security camera setup, I'd be tempted to, instead of going for this combo, picking up this and a Pi Zero wireless and giving that a go. Roughly the same price, but you're going to get the better performance. I guess it really comes down to what your use case is going to be. Now, the part of the video I am really interested in is I want to know how this stacks up. This is the Raspberry Pi 5 with the AI hat on top with 26 TOPS of power. I initially purchased this device thinking it would help with large language models. I wanted to run AI locally and talk to it. Unfortunately, the Halo 8 chip, which this is built with, can't be used for large language models. But what it can be used for is image detection. So we're going to connect the Pi Camera 3 and see how much of a difference the AI hat makes for that performance. Now, during my research for this video, one of the questions I had was, should I use the Pi Camera 3 with this, or should I use AI and more AI? Use the AI camera with the AI hat. Based on my current understanding, we can't use these devices together. You can either use the onboard processing or the AI hat processing. I don't think there's an easy way to do both. Happy to be proved wrong in the comments down below, but for that reason, that's why we're sticking with the Camera 3. Connecting the camera when the AI hat is already installed is a little bit tricky, so if you're starting from the start, I actually recommend you install the camera first and then put the AI hat on top. But with the Raspberry Pi 5, there are two camera slots, 0 and 1. We want to do 0, which is the default, so we're going to gently lift the tabs on either side, and it is very tricky to get to. Now, unlike the Pi 4 where we had the blue strip facing the Ethernet port, this time it's going to be the opposite way. We're going to have it facing away. This is going to be very fiddly and tricky, so I'm just going to describe and do it off camera. Basically, same as before, slot it in, press the tabs down, and then power the device on. I also forgot, because we're doing this on the Pi 5, we are going to have to use that different ribbon cable which had that thinner slot. So I'm going to just quickly go ahead and do that. Slot that out, put the new one in. It's kind of funny, the very first time you do it, you're very scared that you're going to break something, and then after doing it lots and lots, you totally get used to it. There we go. And once it's installed, it should look something like that. We're going to go ahead and give it some power. To get started, there are two things you need to do. Now, number one, I've already done this first step, but I'll just quickly show you. Following their official guide, you need to make sure that you run these commands to make sure you're running the latest software and firmware. Basically, steps 1 and 2 in this guide, which I've already done. Once you've done that, head over to this GitHub page where we have all of the examples which make use of the AI hat. We're going to go ahead and clone the repo. So if I head over to our Raspberry Pi, I'm going to make a temporary directory, and I'm going to go into there, and I'm going to run our git clone command. Next, we're going to cd into the folder that it downloaded. Go ahead and run the installation scripts. This starts up the Python virtual environment, which has all of the dependencies we need for this to run. That's what this is in brackets here, which lets us know we're in the correct location. Now we can go ahead and run some of their basic examples. This is a simple video feed where it's detecting all of the different objects, and straight away, even though we don't have frames per second, we can see just how well it's handling a large volume of data. Now we're going to go ahead and run object detection using our actual live video feed. This is the command we want here, with our input being the Raspberry Pi camera. There I am. It's running really smooth. How about a phone? Oh, yep. Phone with a lot higher confidence and just really quick. Not quite. Questionable. Suitcase. Some questionable results there, but super smooth. I don't know if my screen capture is doing it justice, but this thing is almost instant. Anything I zoom in and out of frame, it picks up within milliseconds. Based on all of the tests we've done today, if you want like top tier millisecond performance, Raspberry Pi 5 with the AI hat and the Pi 3 camera is going to give you the best performance in this ecosystem for object detection. But it's also the most expensive option. A close second was the AI camera. We got a solid 30 frames per second. Now again, because all the processing happens on the camera itself, it doesn't actually matter which Raspberry Pi you pair this with. And it should, in theory, still give you the same performance on even the entry levels like the Pi Zero Wireless. Now we did verify that tracking only with 1 or 2 subjects. If your use case was to track like 30, 50, hundreds of people in traffic, you'd probably still have to go for the AI hat option. But for most people, I think the AI camera is going to be a great choice. And finally, we had the Camera 3. If you've already got a Raspberry Pi 4 or 5, you can get away with using this camera. It's a lot cheaper. Yes, you're going to get limited frames per second, but if you're using it for simple home automations, it's going to be fine. Ultimately, it's going to come down to what your use case is. But I think all 3 of these setups are going to be ideal for majority of use cases. For myself, I would love to replace this Aqara presence detection sensor. This hooks up all the automations for my office lights. So whenever I walk into my office, they turn the lights on automatically. And then when I walk out, they turn them off. It's great, but it works 80% of the time. And sometimes it turns on without people there, like it detects ghosts. I'm hoping I can instead replace it with this setup. I think that would be pretty cool. Now, I wouldn't want a video feed 24/7 capturing 30 frames per second and processing that and just getting really hot all the time. We'd probably have to write a script to, I don't know, take a picture every couple of seconds, and if person detected, then do something. And we could potentially train a model to recognize my own face so that it only works for me. But yeah, that is what I'm really hoping to do with this in a future video. That was a comparison video between the different cameras. And again, big thank you to Raspberry Pi for sending out that AI camera, which made this video possible.